What's up, everyone? I'm Brian Gleason with MLC CAD Systems, and I want to talk about multiplying your programming capabilities using AI. So, artificial intelligence, AI, is growing rapidly in power, and it's being implemented in a lot of different places. And so, why can't we use it for our machining or programming? Where is it being used? Well, we're seeing it in our phones, right? You probably have a smartphone. It's probably got an app in there for AI. Maybe it's even using AI to help alter some of your pictures. We're seeing it in our cars, or some cars. So we're getting, auto driver, all kinds of other stuff. I don't have one of those fancy cars, so I don't know the terms. Search engines. So if you went to Google something, you're going to see that they have an AI overview giving you a quick synapse of what they found. So again, what about for our machines? Why can't we use AI to help us with that? And I know what you're thinking. No, I'm not talking about these machines. I'm talking about our CNCs and being able to program. So what we're going to be looking at today is Cam Assist from CloudNC. This is going to be an add-in that is going to use cloud-based AI to help get you pretty close to done on your programming. If you guys made it to our manufacturing day, you probably remember this part. And if maybe you guys were in any of our training classes, you might have remember how long this part took. So I'm just going to run through it real quick. Just a few simple clicks. I'm checking for my license. I'm just going to go ahead, green check, go, and let's give this a thought. So how long would this really take you guys? And everybody's going to be pretty quickly. Maybe you have all your toolpaths exported and you're going to import them in, reapply geometry, and set all your tool speeds and feeds. And if you were in my essentials class, you're going to see that this probably took half a day for this first part. And on this, what do we take? Seconds. So there's our first part. And again, this is just quick synapse of how quick and easy it is. Now, what's involved with getting this to work correctly? So we're going to look at setting up for Cam Assist. And I'll go ahead and open up another part here. And on this one, we're going to go look into the machine group properties and see what we have. So in the machine group setup, it's just like we just brought in the machine. I already lined up the vise, already created a wireframe for my stock. So let's go start using that. To make sure that we're getting Cam Assist all the information it needs, we need to select our master model. We need to give it a good stock so it knows exactly what area it's working in. Let me make sure I find the right point. And also fixtures. So I'll make this quick and easy, vice 1. So once we have all the information needed, we can go through, run, and we'll get our toolpaths going. So like anything that, it's going to be somewhat automated, it's going to need all the correct information to get it the best results, to yield the best results. So maybe it's a little bit of a step to get in there, but once you get a few reps at setting up a part and adding fixtures, it'll go pretty quickly and easily. Plus, while this is doing everything for you, again, it's pretty dang quick. And just to give you a little thought on this, we'll select it and we'll go into our verify to see what everything looks like. Pretty quick, pretty nice. I even have a nice little edge break, so we don't have to deburr. Unless you guys like deburring. Let's look at it a little bit closer. Let's give this tolerance 5 thousandths. Run through our compare. So if you look on the heat map, anything that's green is plus or minus 5. All the blue stuff is where we didn't touch it. There's a little bit more than 80% on that first operation. I'd be happy with that. I don't think everybody's part is just one side and that's it, right? So let's look at being able to do multiple setups. So in this file, I've already got it pre-set up. Let me turn off translucency, make it look a little easier. We have op1, we have op2, and op3. So to go through the setup that I did for this, we'll go to machine group setup for machine group 1. We have our master model. We have a solid for stock. We have our fixtures. Machine group 2, we have the master model, no stock, we have our fixtures. And then lastly, machine group 3, which is going to be master model, no stock again, and then we have our fixture. So we'll go ahead and get into the Cam Assist and look at doing multiple setups at one time. So let's go run through the settings. We're going to use the Cam Assist tool library. We are doing 3-axis mode, and we're going to do machine group 1. Yes, I want to do it. Selected plane is going to be top. We're going to do machine group 2. I've created a plane that I want to use. It's going to be op 2. Machine group 3. I have a plane I have for that one, op 3. So I did have to go set up with the different planes. That's how we get the nice views. Tool use. Oh, I forgot to mention. So maybe operation 3 isn't very rigid. You can adjust some of the speeds and feed parameters or tool sizes based off your work holding security. So you get a nice little slider for that. Tool use. I'm going to use the Cam Assist tool library. You have the option to pick whatever libraries you want. I'm going to stick with this one. Our material, we're going to go with the base aluminum for our material, and then we'll go with 7075. We can set some of those up as well. And then I'm going to use cutting parameters, so use speeds and feeds for the selected tool library, or use Cam Assist to generate. If I had my own library and I had some proven speeds and feeds that I liked, and I set those up in the cut parameters, Cam Assist will pull those in there and use it. We can tell it to use only our speeds and feeds or only use CloudNC cutting parameters. On the advanced page, what are we going to be doing? We're going to be face milling. We'll do bulk roughing. I'm going to leave detailed roughing off, and we'll do finishing, hole making, spot drilling, deburr. We'll machine full apart. We'll patch any holes, so it's going to create little surfaces to make sure that the toolpaths go over the holes, don't try to dive in, and that's a nice feature. We're going to do finishing by order type. We're going to do area milling for finishing flats, and then any freeform, which we have a couple, we're going to be using a waterline. Do we want a deburr? We'll go ahead and use a chamfer mill, and we'll have it generate the toolpaths. I'll go ahead, green check, go. I can go work on other things. I can be doing a lot of other things while this is basically programming the part for me. I want to go ahead and look at some other options while this one's processing. So let's look at programming for tooling. I have a part here, and I have a nice little contour jaw, custom shape for our part. I already deleted the part, but sorry. Our 3D printer wasn't available at the time to print out the jaw for me, so I'm gonna actually have to machine it. So do I want to spend all the extra time programming that, or can I let something assist me with that? So let's look at that setup to do the jaw. I'll go into machine group properties. This one's going pretty quick. We need to give it a master model. So I'm going to use the actual model jaw that I did, the one that I relieved for the part, as my master model. Stock, we need to set that up so it knows where to cut. I'll select the jaw, and fixturing, we'll turn that on. So I'll select basically everything. There's device, and I don't need those, but it makes me feel good. And then here's my little half-inch parallel I put in there to make sure that it doesn't hit that one as well. And we'll turn those on so we can use them in simulation. Tool settings, again, not messing with. We now have it set up. We'll go into our Cloud Assist, Cam Assist. We'll do 3-axis, and I already have a plane, op 2 jaw. Good with that. We'll use the Cam Assist library, and I'm going to do aluminum 7075. So basically all the same settings I had. I'll go ahead and let that run process and see what we end up with. Again, able to run a couple sessions, get everything done. Basically, it looks like I have 3 programmers running at the same time right now. So it's going to tell me if we checked some of the holders, trimmed out some of the toolpath. So we'll have our stock model, our first roughing, stock model, and then it'll do a nice little progression, just like I would program anyways. And then we have a few flats. Let's give that a look. and I'll go ahead and run through our verification. So when I said 80%, yeah, it's going to get you to that 80%. Could I probably delete some of the edge break all around the top? Yeah. Or I can leave it, makes it nice clean, or I can modify it to just cut this area. Some of these corners, the tool library didn't have anything relieved that long, that deep. So I could come back and modify that tool path and make sure it gets that deep, or I can put that part in there. It is angled, so it might not be hitting there anyways. We'll give our next part a look. Awesome. So it's already planned and created the toolpaths up in the cloud server, and now we're just downloading them and we're going to be regenerating them. So now this is basically just dependent upon how fast my computer is. Let's see what else we can move on with on this one. So the jaw, happy. I'm good with that. Was able to get that programmed. We can spit out code, get something going. I bet your boss will be happy with how fast that went. Yeah. So let's look at what other options we can do. Cycle time estimating. How much time are you spending trying to get an idea how long a part's going to take, and then ending up not actually getting the job? So let's look at that. The CloudNC has a nice cycle time estimator. And with this, you do need to set up the parts already. So I went and I set up my fixtures, my part, master model, and stock for several parts, and I placed them in a folder. So I'm going to navigate to that folder. So now that I've selected my folder, I'm going to have each one, estimate 1, estimate 2, estimate 3. I can say yes or no. I can remove those. So maybe I remove 3. I didn't need all of those. I'm just going to do 1 and 2. I'm going to make sure that I don't have anything else. Sometimes it will save on to the old estimates. I'm happy with that. We're going to hit and click run. And what it's going to do, it's going to look to that folder. It's going to pull in each part file and start programming it. And then it'll break down, move on to the next part, give us a good estimate on those. Let's see how life's going on with our multi setup. So it looks like we're finishing up doing the freeform on op 1. This is what happens. Let's see how busy I can keep my computer. So I guess this is where you can go check on how the machines are running. You can go get yourself a coffee break. All right, so it looks like we're getting pretty close to done with our cycle time estimates. I probably spent 15 minutes trying to get everything set up for all of the cycle times. And it's going to come out and it will tell me part 2 is going to take, I believe that's 18 minutes. And then part 1 is going to take us 15. But wait, there's more. Estimate 2. Say I want 25 parts. 25 again, there we go. And on part 1, I want 40. So now it's going to tell us that it's going to take 10 hours, 30 minutes for a complete run. Granted, it's not handling part time, but that's just machine cycle time. And then we'll have 7 hours and 49 minutes on op 2. Now we can also export these results. So I'll export those out. I'll give those a quick look. I hope this works. We have our Excel. I'll open that up. And inside of here, we'll have, here's the part. Here's the cycle time for 1. How many parts do we need to run? And then what's the overall cycle time? To give us the volume size for the stock, how many faces are machined. It will tell us how long each operation took, and you can really break it down. Estimate 1, so part 1, 15 minutes, almost 16 minutes. How many parts did we actually want? And then what is the overall cycle time to do 40 parts? Again, it's not talking about part handling time, but that is just cycle time. And then our volume outline. What can I do with this information? I'm going to be able to get a good quote. I can probably fudge in any part handling time. Maybe I know it's going to take 1 minute to change out parts, and then I can just add 40 minutes to the overall cycle time. I'm going to be able to do better scheduling and get everything planned out and be able to say, all right, this machine should be running this part by here, and I can go communicate that to my customers if needed, or management, whoever needs to know that information. The biggest thing is I didn't spend a lot of time to get a quote out. I didn't have to program a part just to have an estimate on. So again, it's going to be able to help us get more quotes out faster. Now, what do we got going on with our multiple setup? It looks like it's starting to finish up everything, and that's just seeing how fast my computer is. So we got machine group 1. Again, it's going to start a stock model, and then it'll progress through there. Machine group 2 or op 2, it'll give us a stock model. Let's see, so I can see what that setup looks like. I can see my parts sitting in there. Let's see what the toolpaths look like. And then finally, machine group 3, we'll go ahead and see what that setup looks like. So here's my little trick. When I'm doing the multiple setups, I'm going to go to the last one, because it's always going to start off with the stock model from the progressions of the previous machine groups, and I can see what that looks like. So I might go back and revisit Operation 1, refinish some of these. I know it's going to come back and finish this with those walls, but maybe these angles I need to come back. Maybe I need to add an operation. I still got a majority of this done, and I think it took about 10 minutes or so to process all three operations. We'll go ahead and give a quick look. I can see my toolpaths, and everything looks pretty dang good. So let me look at my hole making. I see 2 that I don't like, so I can go modify those real quick. Let me pinpoint which one it is. No. So that one, definitely going too deep. I'll go fix my parameters. Zero that out. This one we'll do the same. Turn on tip comp. So those are corrected. Let's go give it a look. And see how verify looks. So definitely decent looking part. I'd be happy with it. It would get us well within that 80% complete. That was 3 operations. I didn't run through all 3 of them. To recap, using Cam Assist from CloudNC, it's going to help us get things done faster. So it's going to save time, get us to that 80% done. It's got a pretty intuitive interface, so there's not a lot of buttons to click. It's going to be easily to use for a lot of different users. Maybe you have a rookie user that you just teach him to get set up, and he's going to be able to get some parts out faster. For the veterans, it's going to help you get some of the parts out faster. I know I've never met a programmer without a little OCD, but we'll come back and we'll fine-tune any of the toolpaths we need. It's going to free us up to get more work done. I mean, I know that some of you guys might have a backlog of programming. This is definitely going to be able to help with that. You're going to get quick cycle time estimates, right? If we need an idea of how long something's going to take, maybe, hey, can you give me a quote on this real quick? Yeah, you go set it up, you let it run, go grab a coffee, come back, and you have a quote done. That sounds pretty good to me too. So hopefully you guys enjoyed this. If you have any questions, let us know. So multiply your programming capabilities with AI. Thank you.